Today in this lecture, we're going to discuss Chapter 52, an introduction to ecology and the biosphere. Now, what is ecology? Ecology is a scientific study of interactions between organisms and living and non-living components within environments and their factors within the dynamics of that. These interactions determine distribution of organisms and their abundance, and usually these interactions are studied by ecology. Ecology helps us have a better understanding of the earth, better understanding of organisms, do a better understanding of environmental dynamics and social dynamics. So this is a good study to let us have a good thing, which in this study there's also things that talk about birth rates, death rates, in the future more going in depth about ecology. Now there's many different branches of ecology. Within ecology is organismal ecology, which is a study how organisms, structures, and physiology for animals and their behaviors meet environmental challenges. So that's just basing off of like how does an organism meet their challenge of their life, and how do they get past their obstacles. So that includes the physiology, so their anatomy and things, and how they've adapted over years of evolution. Now, moving on to population ecology, which kind of focus on factors affecting their population size and things over time. So that's talking about birth rates, death rates, predators, threats there, things like that, extinction and things, dealing with that kind of numbers. Then moving to community ecology, which is examining interspecific interactions within a community structure. So that's like things that are not really specific, but they have interactions with them. So like it could be things that changes like such as pollution, even human activities. So that's just showing us how communities interactions are changed based on interactions due to the community. And then ecosystems ecology is going to especially show us energy flow and chemical cycling in between organisms. So that's just showing factors of the water cycle, carbon cycle being affected by things like pollution or its benefits to other things, and then transfer energy between animals. So that's a study dealing with that and interactions within that, dealing with biogeochemical cycles. And then moving on to landscape ecology, which is focusing on structures and energy and materials within environments and how they affect the animals within those ecosystems and ecosystems themselves. And then talking about global ecology, which is the biospheres, talking about completely the ecosystem, all planet, and ecosystems within their different types of variabilities within their structures like that. And global ecology, talking about on a global scale of influence of energy throughout the world, levels of birth rates, death rates, pollution, threats, and things that are hurting the biosphere, benefits of the biosphere, and ecosystem services, and things like that. Now, talking about the Earth's climate, it varies by latitude and season, um, and changing rapidly. So, long term, prevailing weather conditions are in an area of constant, which is climate. There's four major characteristics of physical components when it's talking about climate, which is temperature, precipitation, sunlight, and wind. And within that, that causes also different types of biospheres and environments and ecosystems. So climate plays a big environmental factor when it comes to ecology. Global climate patterns determine larger and by solar energy and Earth's movement, so like Earth's orbit and tilt and stuff like that, and radiation from the sun determines a lot of type of seasons. So like right now, at the time of the year, this time of the year right now, it's going to be starting to get colder in the fall and things like that. So how Earth is tilting going around the sun and everything like that. Now there's the warming effect of the sun, which establishes temperature variations, air, water, and evaporation water. So like closer to the equator, you're going to be warmer environments and things like that. And so this leads to, latitude variations. What I was talking about, the closer to the equator is going to be the middle latitude, which is going to be warmer, but the farther away, it's going to be colder and different type of geographical climates there. Continuing talking about latitude variations, because the sunlight intensity is different at latitudes, so the angle of the sunlight hits the earth affects the surface of the earth different, the amount of heat and light that per surface gets. So the intensity of sunlight is the strongest in the tropics, and because it strikes there most directly right there at 0 latitude, and that's going to be right there near the tropics and things like that, and that's where the sun is going to be hitting the most on the equator because that's seen in the picture here, and then the lower angles at the top near the Arctics and stuff like that. It's going to be colder up there, not much sun getting there, much heat getting there. Now, global air circulation is a big thing that plays in here, especially also with precipitation patterns. Global air is going to circulate with precipitation, such as water evaporations in the tropics and warm, wet air masses that flow through the tropics forward to the poles. So that's going to be like, ocean currents and stuff of air that come through near the coast being warmer and things. But within the tropics, it's going to be high humidities and stuff like that, which rising air masses, releasing water, high participation rates, such as in the rainforest. There's a lot of rain and stuff being produced there due to those evaporations and density there. Now, air flowing closer to the Earth's surface makes global wind patterns more predictable and things like that, such as the cool wind trade and warm wind trade of things, such like East Coast currents, um, or not East Coast currents, but like currents near the Gulfs and things like that. It influences like east to west temperature zones. Now, talking about bodies of water here, they have some influences on biosphere, such as ocean currents influence a lot of climate nearby terrestrial environments, such as, uh, currents flowing towards the equator might usually be colder water because it's water being coming from the poles, which then water flowing away from the equator is usually going to be warmer because of the latitude variation is going to be hitting there and warmer there, and at the Arctic poles it's usually colder. That's why colder water is that way. Now, air is going to be cooled by or warmed by these currents as it passes through the land and pushes through these environments. Large bodies of water are going to be moderate climate nearby land, and then during the day, air rises over warm land and draws a breeze from colder water. So, like at night, it's going to be colder throughout, an area, and the day is going to be warmer. So that's kind of like how the air rising and de-rising, promoting the temperatures. As land cools at night, air, like I was just saying, that's how it's going to be if that last bullet point. But bodies of water have effects on air currents also due to its current of warm water coming in or cold water going out. We talked about climate a little bit earlier. Now we're talking about microclimates, which refers to fine and localized certain patterns in smaller little environments. This can be featured like in a rainforest or forest in general. These are like certain casting environment. These are casting climates due to environmental factors. So like the trees providing shade, evaporation from the soil, this changing of wind patterns. So like what an environment might affect on these smaller climates, trees are going to cover more land, so not enough sun's going to get to the plants under trees. More grasslands, it's going to be more evaporation from the soil. Those are kind of microclimates being introduced here. Now, every environment has differences in abiotic factors and biotic factors, which abiotic is non-living contributes to temperature and things like that, or biotic factors being living organisms and living things that have effect on environments. And that's what's going to be happening in also these microclimates within environments. Now, talking about climate change on a global scale, climate is the direction of change of global climate. Lasting 3 decades or more is a type what it means, and it's a global climate. Now, burning of fossil fuels, deforestation, pollution, stuff like that, greenhouse gases in the atmosphere is going to cause a lot of this effect and increasing, climate change and things like that. As a result, wind and precipitation patterns are shifting or global temperatures are rising, which cause environments and other ecosystems to have, effects from this. So global climate change will affect everything overall. Now, there's one way to kind of predict this, and it's due by study over species responded in changes in the past. So this was going to be comparing to like a decade ago and to what is now and what is then and to now. Like how has it changed over then? What is the rise from then? What is the percentages in the ecology within? Now, especially geographic ranges are going to be applied to this, and I was saying it's going to shift ecosystems and things. So it's also going to shift a bunch of species lifestyles due to global climate change. Now, distributing of terrestrial biomes is controlled by climate and disturbances. So biomes are major life zones. Life zones of vegetation or physical environment. So it's either can be vegetation being land and aquatic physical environment, things like that. Now, climate is a major factor here because it's determining locations of these terrestrial biomes and what they are and kind of differences and things like that. Like you're going to have savannas are going to be higher temperatures and not it's still going to be grasslands and stuff, or you're going to have deserts that have no life. It's either super cold or super hot there. And you're going to have, grasslands, tropical rainforests, and things like that, as you can see on the map in the different colors and environments. So climate's going to affect it, geographical things are going to affect it, and biomes are just different types of life zones and areas. It has their own characteristics. Picture from the graph that helps us understand this a little bit better and with on a graphing scale. So annual mean of precipitation as is helping us understand on a level of annual mean of temperature. So temperature compared to precipitation is going to help us determine some of the types of these environments, such as a desert, temperate grasslands, broadleaf forest, a forest, and north coniferous forest and Arctic plains and things like that, the tundra. So that's going to help us better understand the level and why they're that way and why they're different graphically happening due to climate. Now, general features of terrestrial biomes, these are the biomes we talked about that's mostly going to be vegetation, land, and type of stuff like that instead of being morally aquatic. Now, they're going to have major physical factors and climate factors, and based off their vegetation. These biomes are really usually a grade to each other without sharp boundaries, so they're mixed between each other and things like that. Though there's a lot of disturbances present in this, such as storms, fires, human activity that hurts it, like deforestation or wildfires or you know things that pollute the environment, disturb it, and degrade it is also going to happen here a lot. Here's 7 main biome pictures that I wanted to fit in this lecture to show from the book. As you can see, there's our tropical rainforest in the top left up here, and it's near the equator, and then our deserts, not a lot of, still vegetation, but not a lot of heat, not really hot, humid environments like that. And then our grasslands are still high, but still have vegetation and things like that, but not tropic-wise like our rainforest over here. And then our more northern, but grass hills, high hills, no trees, not really in there. Grasslands, mostly grass, not really trees, just like things like that. And then tundra, which is going to be areas of snow and high levels of colder temperatures and things like that. And then our north coniferous forest, what are a bunch of forests and things like that. These are just our main type of biomes I wanted to present and show the different types. And you can clearly see because they're all different a little bit due to their characteristics being where they are latitude wise, climate wise, and their geographical features. Now, moving to aquatic biomes. Now, they're going to be very diverse within dynamic systems that cover most of Earth because, Earth is at least 75% water when it comes to its surface compared to when it's terrestrial on land and everything. Though aquatic biomes are characterized due to their physical and chemical environment. So that's like freshwater, salt water, and things like that. They show less when it comes to latitude variation. They're very, very more relatable compared to geographical factors and latitude affecting terrestrial environments. Um, like I said, oceans are covering 75% of Earth's surface. The surrounding biomes are terrestrial, which patterns of the aquatic environments will affect the terrestrials and influence other things, such as freshwater environments and things like that, and coastal environments that are more mixed in between this. So they have more effect on a lot of things to the terrestrial world, but they are very diverse when comparing the two types of biomes. Within aquatic biomes, there's zonage of light. So this is how much light gets penetrated through there, the strata zones, of how much the depth of the light can go to photozones and affecting and helping vegetation and other organisms within that. So the first upper layer, which is the photozone, has significant light getting through, helping photosynthesis of aquatic plants and things like that. And then there's the photozone and aphotozone, which make up a pelagic level zone, which is a mix of both, but it's just a lower level where light's still reaching, but not as much. And then the deepest level, which is the abyssal zone, which is really deep, usually about 2,006 or 600 or 6,000 meters deep, because that's where there's no sunlight getting through at all within these zones. And then organisms within the very bottom, and that is called the benefic zone, which is the settlement at the bottom. These are where organisms that rely on things coming down there and living off stuff at the bottom of the ocean. That is the benefic zone, so that's our like ground. And then right here will be our abyssal, and then aphotic, and our photic zone right here. Just how much light penetrates is how these zones are determined. Now, talking more about aquatic stuff, we're going to talk about the types of these. You can see lakes, wetlands, streams, and rivers and estuaries are the most aquatic environments that are going to be seen here that are freshwater. Lakes are depending on their size because they're going to be classified as ponds and things, but they're mostly freshwater. Wetlands are going to be surrounded areas that are mostly wet, shallow, and supported by a lot of vegetation and plants adapted to the saturated soil and things like that. Physical characteristics when it comes to playing into what a stream and river is are generally both going to be cold, and their current is what makes them that way. So they're going to be high oxygenated, not really, they're going to really be slow moving and things like that. And then an estuary is the transition between river and sea. So that's going to be brackish and saltwater and freshwater mixed together, which is in the bottom right corner is kind of an example going out to the coast and things. And then right here is a wetland, seeing all the vegetation and still a lot of water. And these two up here are mostly just lakes. I didn't have a picture for rivers and things. But thank you for your today.